Hey everybody, today we are going to be going over the guided notes. It's decimal approximation and rational versus irrational numbers. So our essential question today is, how can you find decimal approximations of square roots that are not rational? And then you can just go to line 4. I ran out of numbers, but I also write kind of big. And it's a question mark. All right, so approximate the square root of 5. So what are the classifications for it? So this is what we're trying to do. We're trying to classify it. So to approximate, you're going to put it in your calculator. You're going to hit the square root button and then hit the 5, and you should get a number that goes on to 2.23606. And I'm putting my ellipse button because honestly, this number would go on and on and on. It has no stop. It does get rounded on your calculator. It does go further on your calculator, but it's going to keep going for a really long time. So our approximation means our about. You remember our little curvy equal sign? We're going to round it to the nearest hundredth. So we're going to look at the number right after the hundredth, which is the thousandths place. It's a 6. So that 3 here, we're going to round up because it has a 6 after it. And you remember, if it's a 5 or above, we round up. So our number is going to be 2.24. About 2.24. So now we know that this number went on and on forever. It looks like it has a stop in the calculator, but it really doesn't. It just gets rounded in the calculator. So this would be called an irrational number. We cannot write this as a fraction. Irrational number. And so what you need to learn from this is that all square roots, and you can put a little sign, I'm gonna put it in a different color, little star, all roots, square roots or cube roots, or really any root that's not a perfect square, is irrational. If it is not a perfect square, it is an irrational number. So let's go do some more about approximation and using rational numbers to approximate rational numbers. So it says, tell whether the rational number is a reasonable approximation or guesstimate about of the square roots. So we have 577 over 408. So let's figure out what 577 is. I'm going to go back to my black pen. Over 408 is. So 577 over 408 is equal to 1.41421, and it goes on and on and on, so I put my little ellipse there. And the square root of 2 is equal to 1.41421, and again my little ellipse. So if we look at it, they're pretty similar. All the numbers are the same for the first 6 digits after the decimal place. So I would say yes, this is a reasonable approximation. Are they the exact same number? No, but they are pretty darn close. So we're going to say yes, this is reasonable. And you can put just yes if you want. This is a reasonable approximation. And for approximation, I put APPORX. That's just the abbreviation for it. All right, let's try the next one. I'm going to put a different color just so they don't blend in together. So now we have 401 over 110. And if we put it into our calculators, we get 3.64545, and so on and so forth. And the square root of 8 we get 2.82842, and so on and so forth. Now, as we see, these ones aren't even close. They don't even have the same whole number. So we're going to say no, this is not a reasonable approximation. Oops, help if I spelled reasonable right. Sorry, guys. And the last one, let's go blue. 271 over 330. So 271 over 330 is 0.82121 ... It goes on, so on and so forth. And the square root of 21 is equal to 4.582575 ... It goes on and so forth. Again, this is not even a whole, doesn't even reach 1, whereas the other one, so this didn't even reach 1, whereas the other one is 4, almost 4.5, almost 4.6. So we can tell that these are most definitely not a good approximation of each other. So no, this is not a reasonable approximation. And so you can look at fractions and roots and see square roots to see if they can be compared to each other and if they are close to number. But sometimes they are, sometimes they aren't. So now let's move on to the next page where we're going to classify numbers. So let's classify these numbers together. Oh, I can't get it to turn, guys, so this is what it is. Sorry, it's a little crooked. All right, so we have the square root of 12. Well, the square root of 12 is going to give us 3.464116 ... So we're going to say 3.4641 ... So we need to classify what this number is. Now I'm going to go back to the other page. Is it on here? No, it is not. So if you look back at your classification notes, you know that it's either a rational number or an irrational number, and between those we have with things within the rational numbers. Well, this is a number that goes on and on and on. That's why I put those 3 ... So it cannot be turned into a fraction. That makes it irrational. Next one, we have negative 0.25. Well, I can turn that into a fraction. I can put it over 100. 25 over 100 it is the same as 1/4. So we can turn it into a fraction, so it is a rational number. Now, within the rational numbers, we have integers. We have whole numbers, and we have natural numbers. Well, all of those require them not to be decimals or fractions, so therefore it is only a rational number. So now we have negative square root of 9, which gives us negative 3. So this is a rational number because it can be turned into a fraction. It is also an integer because it's a positive or negative whole number. It is not a whole number, though, because whole numbers are only 0 and all the positives, and natural numbers are only all the positives, so there is that. So let's go to the next side. We have 72 over 4, which if you divide it, gives you 18. This would make it a rational number. It would also make it an integer because it's a positive whole number. It would also make it a whole number because it is a whole number. It's a positive number without a fraction or decimal, and it's also a natural number. Now, we want to make sure we're giving the best description that encompasses all of them. A rational number, a natural number is going to be our best description of this because it is a natural number is a whole number, is an integer, is a rational number. Natural numbers are all of these. And if we would look back at our notes, and I'll do one down here, we had the rational, and you guys don't have to write this down, just I'm putting it on here, it's in your notes. And then you had inside rational numbers, all integers are rational numbers. And then within integers are whole numbers. And within whole numbers are natural numbers. I'm just going to put it in because I ran out of space. So natural numbers are actually all of these. They are rational, they are integers, they are whole. Whereas an integer isn't necessarily a whole number or a natural number, but it is a rational number. A rational number is not necessarily an integer, a whole number, and a natural number. We're going to go over this a little bit more, and this will be on your test, but just know that there is a difference, and you want the one that's going to give us the best description. So let's get rid of that. So now let us go talk about pi. Pi is a number that you all should know from last year when you guys did circles. It is an irrational number because it goes on forever. You can't make a fraction out of it without making an approximation. And next we have 0.3 repeating, which we already have said is 3/9, which is 1/3, which makes it a rational number because we can turn it into a fraction. And that would be where it stops because it's not an integer, because an integers do not have a fractional part, or they're only over 1. And whole numbers and natural numbers, the same thing. They are not fractions. So therefore, your rational number is just 0.3 repeating is just a rational number. All right, now let's do the square root of 71 to the nearest integer. So square root of 71 is equal to 42614 ... So now it says round to this integer, which is the same thing as rounding to the nearest whole number, but we say integer because it can be a negative number too. So for our nearest integer, we're going to look at the whole part. So it's here, and then we're going to look and see if we should round. Well, it's a 4, so we're going to keep it the same. So the nearest integer is 8. The nearest 10th is going to be, we look at the 4, and round with the number after it, it's a 2, so it stays the same, so 8.4. And then you have to classify it. We're going to classify it. Well, it is a number that goes on and on. That's why I gave these a little ellipse. So it's going to be an irrational number. All right, now we're going to go ahead and say, I'm going to cross this part off. We're not doing the smallest to greatest. We're going to say which is greater, the square root of 5 or the 2 2/3. Well, the square root of 5 is 2.2, and we're going to round to the nearest hundredth, which makes it 2.24. This is 2.6 repeating. Well, $2.24 is less than $2.66, so boom, that's our greater one. This one I'm not even going to turn into decimals because we don't need to. I have a negative and a positive. Positive numbers are always bigger than negative numbers. Next one we have negative 10, or negative square root of 10. So the square root of 10 is 3.162, and then negative 4.8. Remember, we're looking at negatives. The smaller the negative, the bigger it actually is, because it's closer to 0 and getting closer to those positives. So this is our smaller one, so this is our bigger number. And then we have negative square root of 2. Which gives us 1.14, or 414, sorry. Let's try that again. 1.414. And we have 1.413, and this is not rounding, it had a 2 after, so we're going to actually keep it at 4. And with that piece of information, we now can see, well, this 4 is bigger than this 3, which actually makes this, and remember this is negative, a smaller negative, so it's actually, this is our smaller one. And finally, We have to put these numbers in order. So put these numbers in order from least to greatest. So we have the square root, negative square root of 38. Well, the negative square root of 38 is negative 6.6, or negative 6.164. Then we have we're going to take the square root of 100 over 3. So the square root of 100 divided by 3 is going to give us 5.77. And if we round, it's going to be 4. And that's a positive. We have 6.5, negative 6.1, and 5 2/3 as a decimal is 0.6 repeating. So now let's put them in order. Well, our biggest decimal or our smallest decimal is going to be a negative, and if you want to compare them, you can put a 0 here. Negative 6.100 versus negative 6.164 is negative 6.164 is actually smaller because it has a bigger number. So then I'm actually not going to write it as a decimal form. I'm going to write it as the number that was given in. So that would be the negative square root of 38. Then, so now I can cross that off. Now we're going to go with the negative 6.16. Oh, I forgot the 6 here. Negative 6.16. Cross that one off. And that's all our negatives. Now our positives, this should be a little bit easier. 5.774 is bigger than 5.666. So we're going to say 5 2/3 is our next one. And then the square root of 100 over 3. And then finally 6.5. And there you go. That's how you put them in order. You figure out what they are as a decimal. Your homework to turn in on Canvas tomorrow will be turning decimals into fraction and write each fraction in simplest form. Then you're going to write over here, this is a pi symbol, by the way, guys. Rational or irrational. So you're just literally going to put an R and I, whether it's a rational number or an irrational number. Here, you're going to order them. So you're going to need to change them to decimals and then put them in order on this number line. Then you're going to say evaluate the square roots and cubes. You just need to tell me what the answer to each one of those are. And that's it. If you can do this, you should be pretty good off for the test. You're going to turn it in tomorrow, and then we have a activity to do. Let me know if you have any questions. Bye.